Paolo, he is a senior geophysicist, data scientist, and project manager at Eni, with degrees in both geological sciences and physics, which gives him amazing opportunities for all the projects he has done and all the publications. You can see through the link how many publications he has, and he has some patents as well. So he has over 36 years of experience spanning geology, volcanology, and exploration geophysics. Paolo has authored numerous patents, over 100 specialty publications, as I mentioned, and several books, earning international recognition, including prestigious Eni Award. And besides that, he was also a lecturer as a EG member, going through 17 universities in Europe. We are honored to have him share his insights with us, and it's a pleasure to learn from his vast experience, or your vast experience, Paolo, in geophysical innovation and interdisciplinary research. The stage is yours, so the screen.
Thank you very much. Thank you very much for the introduction. Let me share the screen. I hope that you can see the screen right now. Okay, so thank you for the introduction, and good afternoon, everybody. Thank you for attending this EAG local chapter. And today I'm going to talk about integrated knowledge, creativity, and innovation. I will try to explain this modern symbiosis between scientific and humanistic disciplines. And from the title, you can understand that this talk is not strictly technical. I will try to combine technical subjects with also personal opinions, ideas, even including philosophical ideas about the importance of human creativity. So this is the outline of my talk. I will start with a brief introduction focused on several crucial questions about human creativity and innovation. And then I will go directly through several examples of combinatorial creativity and innovation, starting from geosciences, where I show the importance of combining different types of data and models in order to generate creative and innovative models of subsurface. But then I will move to different fields, combining geosciences and geophysics with other fields of human knowledge, including sound engineering, digital music, art, and of course I will explain the role of artificial intelligence in this creativity process and in innovation in science as well as in music or in art. And I will introduce the concept of technological humanism. That means basically combining a humanistic culture with scientific and technological background. And finally, we'll try to give my possible answers to the critical questions that I posed at the beginning of this talk. And I will conclude with some main remarks. So let's start with some important questions about human creativity. What is creativity and where does it come from? The second very important question is why have there been historical periods and locations in the world where human creativity exploded? And is it possible to create a methodology for being creative and for generate innovations? And finally, what triggers and what suppresses human creativity? So the first very important question is, what is creativity? And of course, I do not pretend to solve the problems right now in few slides, because the question is too complex. But anyway, we can say something about creativity. At least we can say that it is not just an event. It is a very complex process. It is a cognitive and emotive process. The other very important thing is that when we combine knowledge in some original way, basically we try to reshape consolidated systems of significances, of meanings. So we try to extract, to give new meanings, new significances to our experience. So basically the creative process, in my view, involves a semantic process. Semantic means that the meanings and the significances are involved in the creative process. So we try to reshape, to give a new signification to old things. And this is a very important component of the creative process. Examples, very famous examples, are a lot of concepts of quantum mechanics or the space-time theory of relativity theory. For instance, in quantum mechanics, more or less at beginning of last century, all the concepts like velocity, position, or trajectory were completely reshaped. And this was the essence of the creative process of quantum mechanics, reshaping the significance of many concepts, of many old concepts in physics. The same happened in geology, in geosciences with plate tectonics, as well as in art, modern art at the beginning of last century, completely reshaped and reformulated the concept of image. And the same happened more or less in the same period in music. So basically, my message is that the creative process in some way involves a semantic process. There are many factors that fuel, that trigger, and that support the creative process, this semantic process. First of all, informational complexity. Of course, if we have many and complex flow of information circulating in our environment, we have good chance to be creative. And of course, also relational complexity is very important. So it is very important to work in multidisciplinary environments, multidisciplinary teams. Of course, we need also to have motivating dynamics and the right leadership. This is very important for triggering and sustaining creativity. Of course, there are also many neurobiological factors that are intrinsic factors of our brain. But probably one of the most important aspects of creativity is the capability to integrate information, technologies, workflows, people. So a key word in the creative process and in the innovation in general is integration. I'm talking about combinatorial creativity and combinatorial innovation. So the message is that integration is important because it can generate new models, innovative ideas, new visions, and new meanings. I tried to summarize this concept in this very simple formula. Basically, if let's suppose that we have two data sets or two methodologies, A and B, and the integration of A and B is much more than the simple sum of A and B, because this integration produces emergent properties that are much more the mere sum of A and B. This is the importance of integration in the creative and innovation process. We know this very well in geosciences, that is our field, when we try to integrate seismic data with magnetic data, with EM, with gravity and so on, with the support of rock physics and geology, for instance, we get a geological model that is much more than the simple sum of the original seismic or EM models that we used for integration. So the integration is much more than the sum of its parts. And for example, here we have on the top panel a velocity seismic section obtained by inversion of travel times. So this is a tomographic velocity section on the top, and in the middle panel we have the resistivity model along the same profile obtained by magnetotelluric inversion. And when we combine them through, for instance, through joint inversion or cooperative inversion or constrained inversion, basically when we integrate these domains, we get a geological structural model that is much more than the simple sum of the original seismic and magnetotelluric models. We will see this concept much better in the next few slides. Indeed, I am going to show you several real examples of scientific, technological, and artistic creativity, and I hope to share with you this vision that all these fields, so science, technology, arts, music, are not separated. They can be integrated together, and this integration gives us the opportunity to generate new hybrid technologies that can reshape completely consolidated concepts, including the concept of a seismic trace, of a seismic section, of a fault, and so on. So let's start from our domain, that is integration in geophysics. Integration in geophysics is extremely important for generating innovative and original models that could not be generated by using separate domains. For instance, let's suppose that we have seismic data, electromagnetic data, and gravity data. We know that at a geophysical level, seismic data is influenced by seismic velocity distribution in the subsurface, whereas EM response is linked with bulk electrical conductivity, and gravity, of course, is linked with bulk density. But if we go more in depth at a petrophysical level, we know that all these geophysical parameters, so velocity, conductivity, density, are linked with each other at a deeper level in terms of rock cross properties. In fact, when we combine all these properties, for instance, through petrophysical joint inversion, we can get rock cross properties distribution in the reservoir in terms of porosity, water saturation, oil saturation, permeability, clay distribution, and so on. So again, the concept is always the same. Through integration, we can get something that cannot be obtained by using individual components, such as seismic and EM and gravity taken individually. We must combine them in order to generate something that is much more than their simple sum. And this is the essence of the creative process. This is just an example by courtesy of my friend Daniele Colombo. And here in this case, we can see very clearly that we have several domains combined with each other in terms of seismic reflectivity, seismic section in 3D, two-section crossing, and we have the seismic velocities, we have density, we have EM, so the resistivity distribution. And when we combine them, we can get a much more robust geological interpretation that cannot be obtained by using each one of these single domains. But we can do much more. Let's move far away from the geophysical domain, but let's remain in it by combining the geophysical domain with another type of area of knowledge that is sound engineering, digital music, and multimedia disciplines. We can apply the same type of formula also when we combine disciplines and technologies. So not only when we combine data, but also we can integrate disciplines for obtaining something more that is new, that is the result of a real creative process. For instance, if we have, let's say, two disciplines, A and B, and we integrate the discipline A and discipline B, we get a nonlinear function of these two disciplines that is much more than their mere sum. E is a nonlinear function capturing the synergy, innovation, or better, the emergent properties that arise when combining these two technologies. And I will show you, I will start with a very interesting example that is the combination of geophysics with sound engineering and digital music. Let's start from the beginning. This is a normal seismic trace, bottom panel here. So on the horizontal axis, we have the travel times, and this is the Stockwell spectrogram that we extracted from the seismic trace using the Stockwell transform. So here we have the frequency on the epsilon axis and amplitude on the vertical axis, and in colors also we have amplitudes. And this is the 3D Stockwell spectrogram obtained by this seismic trace. Again, here the same representation in 2D. Here we have the same seismic trace in the upper panel. In the middle panel, we have the spectrogram obtained by the Stockwell transform, where F is frequency and T is time. And we can do much more from this spectrogram. We can extract a MIDI file from this spectrogram. MIDI means musical instrument digital interface. It is a well-known format used in digital music. And basically in the bottom panel, you have a sort of a musical spectrogram. So it is exactly the same spectrum that you have in the middle panel, but in terms of digital musical notes. In fact, on the vertical axis, you have a virtual keyboard, you have the pitch, and colors here represent intensity of the sound. So basically, we transformed into sounds our original spectrogram using this nonlinear formula between frequencies and note number. So every small piece of this MIDI piano roll display represents a digital musical note. This is a zoom in the reservoir, and red colors means high intensity. So basically, we can play this seismic trace. So we can assign a virtual digital instrument to this MIDI file, and we can play this seismic trace using a digital piano, a digital guitar, or a digital violin, everything you like, every instrument you can select from a digital library. And so we add a new perceptive dimension, that is audio dimension, to our visual conventional dimension. And we are giving a new significance to our seismic trace. Basically, we are reshaping the meaning, the significance of the original seismic signal, assigning to it a double perception possibility, audio and video and visual at the same time. So basically, we are creating something new, a new technology. This is the essence of the creative process, by reshaping through sound engineering the original significance of our seismic signal. And we can do that for every individual seismic trace of a seismic section. For instance, we can convert in music an entire seismic section, like in this example that we published several years ago. Basically, here we have in the top panel, we have a regional seismic section crossing screwed and heavy projected reservoirs. And we have a lot of interesting seismic signatures in this section. And here we have a yellow symbol that, when moving from left to right, will cross the entire section at a fixed depth. And we transformed this seismic section into a MIDI file, sample by sample, trace by trace, so that you can listen to the music of this seismic section. Basically, you have in the third panel, you have the spectrogram extracted at this fixed depth here. So colors means amplitudes, and Here on the vertical axis, you have frequencies, and basically you can convert exactly as I did before in the previous slide. You can convert this spectrogram into a MIDI file here in the bottom panel, and you can listen to the music of this seismic section at this fixed depth. And I'm going to run this music for you right in 1 minute. My recommendation is to listen to this music when the yellow symbol crosses interesting changes of features, like in this point here, where you have a very important lateral change, such as, let's say, faults and geological lateral variations and so on. Let me run this, starting from here. Let's move a little bit more here from here. So of course it is not a nice music, but it is a music, a sound collection that is very dense of significances. For instance, listen to this variation here. And now we move directly on the oil and gas reservoir here, and you can listen to the sound of the reservoir. And here we have a completely different collection of sounds. So basically here we have an example of a double sense representation of the same signals, the same seismic section, in terms of a traditional view in the top panel, but also in terms of spectrograms at a given depth, and in terms of sounds. So this double perception can help us in interpreting the same data using this hybrid technology that was originated by combining seismic concepts from mathematical transforms and with other concepts coming from sound engineering. And another very important aspect of this technology is that we can extract from this MIDI file, we can extract more than 100 MIDI attributes that have no equivalent in the seismic domain. So we have more than 100 new attributes linked with the rhythm, linked with the melody, or linked with the harmony, and so on. So linked with the music parameters that can be used for automatic interpretation through machine learning. And this is exactly what we did in other examples, where we interpreted seismic data using MIDI attributes, going through machine learning, so going through automatic interpretation that was much more robust because it was based on more than 100 new attributes. This is another example where this concept is very clear. This is the spectrogram of an earthquake seismogram, and we can extract from this spectrogram audio attribute, media attributes, seismic attribute, conventional and unconventional numeric attributes, video, and so on. So basically, we can create a multi-feature fingerprint that can be used for making automatic classification of data and data mining, also data mining through machine learning. And this is the sound of this earthquake that is played using a digital piano. So basically you have the standard seismic trace in the two channels, but also a lot of spectral information, and also you have the sound of the earthquake, and you can have the possibility to use a double sense interpretation for analyzing in this dual mode the same original seismogram. We can do much more for interpreting faults. Everybody knows that faults are extremely important in our job, and there are main faults, of course, that are very clear also for a simple analysis, visual analysis of seismic sections, but sometimes there are also many small faults that are not clearly visible and are very difficult to detect from a visual analysis. So we applied the same hybrid technology. We tried to be creative because we applied the same hybrid technology for detecting all the faults, including also the very small faults. So we transformed the section in a MIDI file, and we assigned a particular sound to the faults, including also the small faults. And we can have this type of representation. So in the lower panel, we have the spectrogram of the faults that are crossed by the mouse at a fixed depth, and each one of these discontinuities is a fault or a lateral discontinuity. We have large faults, but also very small faults that can be detected visually on the spectrogram, but also using the sounds. Let's go to listen to the sounds of these faults. Okay, so this was an example of sonification of faults. In my opinion, this display and this multimedia representation of the faults has also some aesthetic meaning, not only technical meaning, but it is also beauty, at least from my point of view. This is the reason why we created an artistic performance together with the famous artists a few years ago in the Royal Palace of Milan, and we made this exhibition, this performance, including art, music, sound engineering, and faults, combining the work of many musicians, artists, and geophysicists in the same place. So we are, in this case, extracting also the aesthetic meaning of our data, of our job. In fact, my opinion is that geology, geophysics sometimes have also a very strong aesthetic and beautiful meaning. So there is some beauty included in our data. And also National Geographic contacted us for creating the background music of their podcast on volcanoes using our geo music produced by our approach as background of the podcast. So again, this is a creative process that is generated by the integration, the combination of different technologies, different disciplines, combining humanistic, artistic, and philosophical, and of course, scientific concepts, and reshaping the significance of these concepts. We can do the same also in medicine, so combining geophysical methods for improving medical imaging and medical diagnosis. So basically, I wrote several papers aimed at showing how many inversion and optimization techniques that we use in geophysics can be used with limited variations also for medical imaging and medical diagnosis. So we can improve the imaging of the body interior using the same optimization techniques that we use in medicine. Again, the same concept. Combination and integration of disciplines generates something new, generates a creative process, generates an innovation. And I did the same also for performing a multimodal analysis of the spoken language and for analyzing and improving some cognitive models. Again, combining optimization mathematical techniques that we use in geophysics, but also combining our hybrid technology based on sound engineering of time series. Of course, the role of artificial intelligence in these hybrid technologies process is extremely important. The first very important concept is that the most recent deep neural networks algorithms derive from a combination of neuroscientific concepts with other fields. For instance, convolutional neural networks comes from the cross-fertilization of neurosciences with AI, with artificial intelligence. The same for recurrent neural networks and for deep reinforcement learning. And we did something more. We created new types of neural networks that are self-aware neural networks that are based on the concept of self-awareness that comes from neurosciences, of course. And also we created dopamine reinforcement learning algorithms deriving these concepts from neurosciences. So again, the combination of multiple domains of human knowledge. And I wrote a book, I published this book with academic press with Elsevier, where I explored the neurobiological background of exploration of geosciences, and where I explain all these hybrid technologies derived from the combination of multiple domains of human knowledge. Finally, there is this other very interesting applications in bioacoustic, where I use the combination of sound engineering, MIDI music, mathematical transforms, and of course biology for creating an automatic method based on deep learning for automatic classification of bird songs. Let me conclude with this example here for remarking the aesthetic sense of geophysical data. So again, a combination of geophysics with art. Last year, we were invited at the Venice Biennale in Venice, where we cooperated with famous artists and even with the Massachusetts Institute of Technology for creating this multimedia performance where I used magnetotelluric waves, so electromagnetic waves, for creating musics after their transformation in digital files, in MIDI files. And so here we have basically you are going to listen to the sounds of magnetotelluric waves that, in my opinion, are very nice, very beautiful, and at the same time very informative, because you will listen to the arrival of low frequency waves very clearly in this music. So they are at the same time very beautiful and very informative. Let me try to trigger this music here. Oh, sorry. So this was my last example that gives me the opportunity to introduce the concept of technological humanism. Basically, we are talking about the combination of humanities and scientific and technological methods in order to trigger, to sustain interdisciplinary approaches that in turn are able to trigger new technologies. So they have not only an aesthetic and artistic meaning, but also a pragmatic meaning. So the interaction between these disciplines can stimulate critical thinking and philosophical reflections about what we are doing in our job every day. And this is essential for our scientific progress and for finding innovative solutions, innovative techniques, innovative methods. So finally, we can come back to our initial questions, and we can try to give some answer, at least partial answers. This is from my personal point of view. What is creativity and where does it come from? I think that human creativity is a cognitive process involving both semantic and emotional aspects, almost always social in nature, that radically transforms the current systems of meanings. And it can be triggered and it can occur in a favorable environment where there are complex informative flows, shared meanings, and the necessary resources for integrating knowledge, technologies, and people. Why there have been periods of explosive creativity in history? Several historical and geographical locations create the ideal conditions for integrating information flow, information meanings, knowledge, and technologies, both at a social and an individual level. So this is not just about the individual genius like Leonardo da Vinci. It is more a concept of shared knowledge among teams, human organizations. And the correct leadership is absolutely necessary for facilitating this process. And examples are Pericles, Enrico Fermi, Picasso, Heisenberg, that had the correct leadership for driving the creative and innovation process in their fields. Can we create a method for creativity? My personal answer is yes, because we can create the conditions for individual and group creativity to emerge by triggering a virtuous semantic process of selection, integration, and resignification of information flows and meaning systems. What triggers and what suppresses human creativity? Of course, there are many factors that involve both individual and social aspects, but in general, creativity is triggered and sustained by complexity. So when this complexity is transformed from chaos into some type of organized semantic structure that we called organized complexity. This is the last slide of my talk, because I want to share with you this my personal initiative. I created a laboratory for creativity in my country house, where there are all the conditions that I listed before for being creative and for generating innovations and hybrid technologies. So in this country lab, I have all the equipment for combining different technologies, for using artificial intelligence, for sustaining this innovation process, and for sharing all the innovations for free, absolutely for free, with all the scientific community. And I think this was the last slide, some references. I wrote several books about these concepts, in particular focused on geophysics and on geosciences, but also involving neurosciences, philosophy, epistemology, environmental sciences, music, sound engineering, and so on. And I really thank you for your attention. Thank you very much.
Thank you very much, Paolo. That was very unusual and very interesting talk.
Thank you.
I will enable now everyone to be able to ask questions. So give me 5 seconds. I'm allowing microphone for all attendees. If you would like to speak, you can just write in questions and answers. So now it should be on. But first of all, that was really interesting to hear Folt's music, and it's the first time I hear the music of Reservoir as well. For sure, it would make the interpretation process a bit more musical.
Yes, basically we have a double sense interpretation mode, and also the important thing is that we have much more attributes, more than 100 new attributes that can help us for automatic interpretation of seismic data or electromagnetic data. So this is the sense of this hybrid technology, improving the possibility to interpret the data.
Fantastic. Okay, so any volunteers to start the questions? Okay, Albine, Tamam, let me. Yeah, you should be able to speak.
Hello.
Hi.
Hello?
Can you hear me?
Yes.
Great. Thank you so much. It was really unusual and unique. I really appreciate it. I would like just to ask about the input for this data to create the sounds. So mainly just one cross-section over the fault systems or the spectrum itself. Thank you.
So your question is, what kind of data can we use for?
Yeah, the input data to create it, like one trace or what?
Yes, we can create. Yes, we can use airborne data, of course, and we can use many other types of data. Basically, we can apply this method to every type of time series: electromagnetic data, airborne data, terrestrial data, and every time you have a time series, you can convert the time series using Stockwell transform or wavelet transform into their corresponding spectrogram, and then you can extract the MIDI files from the spectrogram with that nonlinear relationship that I showed you before. So every type of time series can be transformed in music, basically, applying the same idea, basically.
Yeah, and did you apply it previously for the well logging data? Because it's also able to use in that case.
Absolutely, yes. We transformed, for instance, resistivity logs into music, and and also sonic logs, because that are not time series, they are depth series, but the concept is always the same. Every time we can extract the spectrogram of a signal, we can transform that spectrogram into a MIDI file with a very accurate transformation without losing any information. And so it is a very confident transformation that can put in music your data, including well-logged data, of course. Yes.
Great answer. Thank you so much.
Thank you.
Thank you for your questions. Anyone else? Have you got a chance to implement it in the company, for example?
Yes, we applied it, and we published also some paper for interpreting data using multi-attribute coming from MIDI files. At the moment, it is considered still at an experimental level. But I am absolutely confident that this methodology can be applied at massive level, because because this methodology is based on MIDI files that do not require too much computer resources. MIDI is a very light format. So this technology can be applied to very big data without involving large computing resources.
Computing resources is especially important these days.
Yeah. But when you work with the MIDI files, you don't require large MIDI resources, large computer resources, because a MIDI file of a seismic trace is less than 1 kilobyte. So it is half kilobyte, so less than a SegWi format seismic trace. So it is very, very easy to deal with the MIDI files.
There is a question from Cristiano.
Yep.
Hi, Paolo. Thanks for your talk. You mentioned creativity comes when different domains and backgrounds are working together. Was the team, I guess, creative? With various backgrounds you were working with, published as well? Can you publish as well?
Yeah. Yes.
Cristiano,
yes,
correct me if I'm wrong.
Yes, no, I understood. I understood the question. Yes, the team for doing that must be a multidisciplinary team, of course. Indeed, when we performed the important projects, so the team was a multidisciplinary team, especially when we move in the musical and artistic domains. For instance, in the Venice Biennale of Venice project, people coming from multiple disciplines, artistic and scientific disciplines, including a person coming from Massachusetts Institute of Technology, were involved in the team. Yes, absolutely, the team must be multidisciplinary, because creativity and innovation mainly derives from a multidisciplinary environment. The environment must be complex and rich in ideas and in opinions. So the answer is the team must be absolutely multidisciplinary. In particular, I see an ideal team consisting of sound engineering, a geophysicist, a geologist, a mathematician, a physicist, and an artist. So this is an ideal team.
There is one more question. Would you like me to read it, or you can just answer from Nico in the chat?
I don't see the chat.
Okay, I will read. That's all right. So question from Nico. Thanks for such an interesting and stimulating presentation. I wonder if there are any physical insights that you learned about the seismic data when analyzing it using musical features. What are the main ones?
Yeah, very, very good questions. I discovered using the media attributes that seismic traces have a rhythm, a musical rhythm. And this musical rhythm change when you have different scenarios. For instance, we made a publication that can be free downloaded from my ResearchGate page, where we use the media attributes for distinguishing low gas saturated sands from high gas saturated sands. So a very pragmatic applications. And this was possible using our media attributes because the rhythmic and melodic and harmonic media attributes are different in case of high gas saturation and in low gas saturation. We can say that because we made the calibration at well locations, and we really observed the very different media attributes in the two different scenarios. So my answer to this very interesting question is that yes, we found interesting physical insights in seismic data, but also in electromagnetic data using media attributes and making automatic analysis of our data.
There is one addition to the question. Which media attributes were those?
Okay, there are many categories of media attributes. There are simple media attributes that are directly linked with the pitch, that is linked with the frequency in a nonlinear way. So this is the fundamental media attribute. It is the pitch. Another media attribute, very important, is velocity, that is linked with the sound intensity. And these are the simplest media attributes. Then there is the step-on attribute that is linked with the beginning of, let's say, an important seismic signal. But then there are also many complex attributes that derive from the combination of other attributes. And these attributes are linked with the rhythmic, melodic, and harmonic attributes of the seismic data of the geophysical signals. Okay, you can find in my publication the total list of these attributes. In total, there are more than 100, and many of them have no correspondence with traditional seismic attributes. So they add something new to the traditional seismic attributes.
Thank you very much. We have just 3 minutes left. So
Yeah.
Probably we can take one more question. And then we have to round up. This recording will be published on the EEG YouTube channel. And we will reshare this video once it's published. Maybe it will take a couple of weeks for publication. We will reshare it on our LinkedIn page. So I highly recommend to follow it if you are not following it yet. I mean, I'm talking to everyone, not just to you, Paolo. So yes, Cristiano.
I just wanted to say thanks to Paolo. It was an amazing presentation. I had the pleasure to listen your presentation in Italian and now in English, so it's fantastic. Thanks.
Thank you, Cristiano. Thank you, Cristiano. Thank you for organizing and for inviting me. And thank you to Anastasia and to EAG to this fantastic local chapter. Thank you very much.
Thank you.
And thank you everybody for coming.